Hello and welcome to this pre-recorded event for the June 2015 examination for Unit C1 GCSE Chemistry. To help you get the most out of this feedback, you may want to have the following documents handy, as we will refer to them during the session. Here are the aims and objectives of today's session. You will receive feedback on national performance of candidates in Unit 1 of the June 2015 examination series. Consider the variation of candidates' performance on different questions and possible reasons why. Look at the examiner's report. Address common issues. The next 4 slides will look at question 1A of the foundation tier paper. This is a straightforward description about how igneous rocks are formed. Most candidates performed well on this question, and most were able to state that igneous rocks are formed when magma cools. In this example, you can see that lava was an allowed alternative to magma. In this specification, it is expected that candidates should know how igneous, metamorphic, and sedimentary rocks are formed in general. This candidate clearly knew and wrote more than was required for this answer. There is no need for the candidate to rewrite the question. The candidate gains no credit for this and serves only to waste their time and answer space. A good example of an answer is found where the candidate writes clearly and precisely. Although this question performed well, several candidates confused the formation of igneous rocks with the formation of metamorphic or sedimentary rocks. Some candidates wrote vague answers such as this, which lacked the detail needed to gain credit. Candidates should understand the differences between the 3 classes of rocks and how they are formed. In this question, successful candidates read the questions carefully and answered them as they were set, and did not simply repeat the stem of the question. Used scientific terms correctly. The next 4 slides concern question 4D of the higher tier paper. You will find it useful to look at this question on page 14 of the question paper. You may wish to pause the video at this point to read the question. In this question, candidates were given information about 3 different indigestion remedies, A, B, and C. In the first experiment, a whole indigestion tablet was added to excess hydrochloric acid, and the time for the tablet to react completely was recorded. This was repeated using a crush tablet. In the second experiment, the volume of acid neutralized by each whole tablet was determined. This was repeated using a crush tablet. In Part 1, candidates needed to analyze the information to explain which tablet contained the most active ingredient to overcome indigestion. This was given by the tablet neutralizing the greatest volume of acid, as shown by Experiment 2. In Part 2, candidates needed to analyze the information to explain whether faster indigestion relief was achieved by using whole crush tablets, as given by times recorded for Experiment 1. In Part 1, this candidate correctly identified tablet C and gave the correct explanation about it neutralizing the greatest volume of acid. Many candidates, as did this one, added some comment about the time indicated in Experiment 1, but this was ignored. In Part 2, this candidate scored the mark for recognizing the shorter times for the Crush tablets by stating it was faster by 45 seconds for Tablet A. Most candidates performed well on Part 1, but were not as successful on Part 2, mostly through poor expression or by just repeating the question. For example, Crush tablets because they were faster. This candidate identified the correct tablet in Part 1, but did not adequately explain why Tablet C contained the most amount of active ingredient. The candidate identified that this tablet neutralized 50 cubic centimeters of the acid, but did not explain that this was the greatest volume of acid being neutralized by the tablets. In Part 2, this candidate scored the mark for quoting relevant times to back up the idea of Crush tablets giving faster relief. This candidate identified an incorrect tablet by focusing on the wrong information to answer the question in Part 1. In Part 2, this candidate scored the mark by quoting relevant times to back up the idea of Crush tablets giving faster relief. Several candidates did not gain credit on Part 2, where they wrote about faster times. In this question, successful candidates read the whole question carefully and answered stating that Tablet C contained the greatest amount of active ingredient by making a valid comparison with the other two tablets. Expressed their answer in 2 in terms of lower or shorter times. Look at this example of an answer to question 4A2 on the higher tier paper. Using the mark scheme, decide what mark you think should be awarded and why. This is a point at which you can pause the video to look at the mark scheme and decide on the mark and why. The first marking point is for a correct gas test. The correct gas test here is using a lighted splint or lighting the hydrogen in some way. No mark is given here, as the candidate has not shown that the match used is a light. The second marking point is only awarded for the result of a correct gas test. Successful candidates described the correct gas test, putting a lighted splint into the gas. Gave the correct result for the gas test. Several candidates failed to score on this question because they gave an answer similar to use the squeaky pop test. This answer contains no correct gas test, and so cannot score any marks. Other gas tests in this specification would be marked similarly. Oxygen. The test is using a glowing splint. The result is that the splint relights. Chlorine. The test is using damp litmus paper. The result is that the litmus paper is bleached. The next 4 slides are about the calculation in question 3B2 of the higher tier paper. Take a moment to read the question on page 11 of the question paper. You may wish to pause the video at this point to read the question. This calculation made here by the candidate was an incorrect attempt at finding the volume of 21%. It's not certain how the final answer was obtained. This answer shows a similar attempt at the calculation and scored no marks. If candidates had the first part of the calculation correct, they obtained an answer of 10.5 cubic centimetres, which is the volume of oxygen present in 50 cubic centimetres of dry air. For this, 1 mark was awarded. To score the second mark, this volume had to be subtracted from 50 cubic centimetres to give the volume of gas remaining at the end of the experiment. This shows an alternative approach to the calculation, for which the candidate scored both marks. The candidate realised that the percentage of gas remaining was 79% of the original volume, and calculating that gave the correct answer. In the mark scheme, it shows that where candidates give the correct answer alone, of 39.5 cubic centimetres, both marks were awarded, even if there was no working shown. Please encourage your candidates to show the method of working. Less successful candidates used an incorrect method of calculating 21% of 50 cubic centimetres. Did not show the method of working. The next 4 slides are about word equation and balanced equations that appeared on both the foundation and higher tier papers. The top word equation question is from question 5B of the foundation tier. The line immediately above the question gives all the relevant information needed for the candidate to use. Word equations should only contain names of substances and not their formulae. Here an incorrect attempt was made at writing the formula for water. A reactant was missing, and oxygen was written as a product, so no marks were awarded. The lower balanced equation question is from question 5B2 of the higher tier paper. The candidate has chosen to answer this question by giving a word equation. No marks are awarded for giving a word equation where a balanced equation is required. The top balanced equation is from question 3B1 of the higher tier paper. The word equation was ignored. On the other equation, the formula for oxygen gas on the left-hand side is incorrect. The right-hand side of the equation is correct, so 1 mark was awarded. For the balancing mark to be awarded, correct formulae have to be present on the left and on the right of the equation. The lower balanced equation question is again from question 5B2 of the higher tier paper. Correct formulae of reactants and products are given, but there's an attempt to balance the equation, so 2 marks could be awarded. The top word equation question is from question 6B of the foundation tier paper. The candidate has used the information to give the reactants on the left and has correctly identified the products, so both marks were awarded. Carbon monoxide would have been allowed as the gaseous product in place of carbon dioxide. The lower balanced equation question is from question 6C of the higher tier paper. The candidate has given correct formulae of the reactants and products and shown the balancing method to eventually give the balanced equation. All 3 marks were awarded here. Less successful candidates did not read the information given when writing a word equation. used chemical formulae in word equations, made errors with names in word equations. For example, calcium dioxide in place of carbon dioxide. Used incorrect formulae in balanced equations. Used lowercase letters in place of uppercase letters, as shown on the screen. Did not balance the equation. Look at this answer for question 4B of the foundation paper. Using the mark scheme, decide what mark you think should be awarded and why. This is a point at which you can pause the video to look at the mark scheme and decide on the mark and why. Here, 3 marks were awarded. 1 mark for the colour of the bromine water. 1 mark for the change to colourless when reacted with an alkene. 1 mark for bromine remaining orange with an alkane. On this question, successful candidates identified the correct colour of bromine water, gave the correct colour change with an alkene, showed that bromine water had no colour change with an alkane. On this question, less successful candidates did not include the correct colour of bromine water, described the changing colour with an alkene as turning clear or transparent, gave an incorrect colour change with an alkane, or even the reverse changing colour. In order to improve their performance, candidates should learn the definitions of the key scientific words and phrases, learn the reactions in the specification, revise the experiments carried out during the course, learn the formulae of common elements and compounds in the specification, learn the tests for all of the gases in the specification, for example hydrogen, practice analysing data from tables and comparing 2 or more items. Learn to write balanced chemical equations using correct symbols for the elements and compounds found within the specification. Here are some useful links for examination statistics and grade boundaries. We have just published our specifications on the Edexcel website. They have been published early in draft form to enable teachers to have early sight of our proposed approach. We are also running a series of launch events. Our draft specifications and sample assessment material, as well as further information about our launch events, can be found on edexcel.com. Thank you for taking part in this event. You will soon receive an email directing you to an online feedback form. The form takes no more than a couple of minutes to complete. Please let us know your thoughts by filling in this short form.